Okay, so welcome to this lesson, which is on further graphs, and it feels like we've drawn quite a lot of graphs recently. So this is the end of this unit, and these are going to be mostly graphs that you've never seen before. Some of them you might have, but most of them I think will be brand new to a lot of you. Now, if you want to do this video the way I would intend you to do it, then actually you're going to pause it along the way and do quite a lot of thinking. And that's kind of like by the end of this lesson, you should know all these new types of graphs, and I'm going to make you make a summary of those. So in your book, you'll have a nice set of notes with a summary of everything that we've learnt today. But if you want to do this lesson really well and you want to get something a bit more out of it, what I'd love you to do is every time I say pause is to actually do that and play around with those graphs and really try and work out what those graphs might look like. Now, clearly, you could just press play and watch me do them, but if you do that, then what actually happens is you don't in a week's time, you'll have forgotten all of this. Whereas if you spend that time playing, you get to practice your problem solving skills, all of those things that you'll need for an exam one day, but also you actually kind of get your psyche around how these graphs work and why they work as they do. So that's my advice, is please, 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 when I say stop and press pause, please do that and just sort of play around with the graph and see what it looks like. So we've sent you a document that looks a little bit like this, and the aim is that what I would like you to do is in your book by the end of this lesson is have all of these summaries that you can see on the screen. All of those need to be in your book. Everything else we do today is just you experimenting. The actual summaries are the bit you need in your book. So let's start with the quadratics. And I hope from the work we did last week, you should know from what we did that actually if you draw an x squared graph, you get this nice U shape that looks like that. And we call this a parabola in maths. And anytime I'm trying to draw a y equals x squared graph, it's going to have this very distinctive parabola shape. Hopefully as well, from the stuff we did last week, you also know that if I put a minus sign in front of it, I can't get my camera right today. If I put a minus sign in front of it, it flips the graph upside down that way. Okay, so when I draw y equals minus x squared, it flips my graph upside down. Next up, cubic graphs. Now, cubic is something with an x cubed in it. So I'm going to draw y equals x cubed. Now, you may or may not have seen this type of graph before, but if you haven't, I'm going to tell you that an x cubed graph is this kind of shape. Okay, so it flattens off momentarily in the middle here and then starts again and makes this distinctive wiggly worm shape. Now, a cubic could also look like this, and that happens when I've got some other stuff after the cubed, so maybe some x squareds or some x's or something like that kicking around afterwards. So if it's just x cubed on its own, nothing else added to it, you get this wiggly worm shape that looks like that. But you can get an x cubed graph that dips in the middle here, and that usually happens when there's some extra terms after the x cubed. So this kind of thing might come up in a multiple choice question. They'll say which of these is the graph of x cubed, and you have to work out which one. Be aware that this has got an x cubed in it, it's got some other stuff as well. And hopefully by now you're getting to grips with the fact that a minus sign, I'm getting to grips with where the camera is, flips a graph upside down. So it'll be this way up if I want to draw minus x cubed. So you need all four of these things in your notes as a summary of graphs you should recognise, and mostly you'll have to recognise those in a multiple choice question. So you need to pause the video and make a copy of those into your notes, and you might need to rewind a bit if necessary. Okay, next up, I'll sort out the camera work while you get those in your notes. Is we're going to look at some graphs that maybe you haven't seen before. So I'm going to start with the graph 1 over x, and I'm going to try and work out what that graph looks like. And here's where I want you to play along with me. Okay, so I'm going to do a couple of points, and I'm going to show you how to put it onto that Word document so that you don't have to find some graph paper or even draw this out by hand. It's right at the limit of my technical skills though, so it may all go wrong. So let's do the untechnical bit first. Y equals 1 over x is the graph I'm trying to draw. So I'm going to look at that graph paper in front of me and pick an x value off that graph paper. So I'm going to pick 2. And the rule says to find the y value, I need to do 1 divided by that x value. Now you may at any stage today use your calculator. I'm interested in the graphs, not so much in the calculator. I'm struggling to show it up on, that's better. So if I can't do 1 divided by 2 in my head, I'll do it on my calculator, but hopefully you're all happy that that is 0.5 or a half. It's really important in this graph that you look at the values sort of between -1 and 1, because quite a lot goes on between -1 and 1. So I'm going to pick, say, -1/4 for my next one. Okay, and when you pause the video, what I want you to do is just pick loads of x values to try and work out what this graph looks like. And pick lots between -1 and 1, and definitely see what happens when x is 0. So I've picked -1/4, and so now I'm going to do 1 divided by, let's put it as a fraction, 1 divided by, and in here I'm going to put -1/4, and good practice always to put my negative numbers in brackets, just because sometimes it's really important that they've got a bracket around them when I do it on my calculator. So I've done 1 divided by -1/4, and that's given me -4. Now, saving you from drawing all of this out, what I'm now going to do is I'm going to just try and put that straight onto the graph. Now, it hasn't gone very well in practice, so apologies if my technical skills go a little bit wrong here. I'm just going to press Control-C, so I've got it copied for later. And the first one, and hopefully you can still see that on the corner of my screen, that I want to plot is 2, 0.5, so I put that there. Now I'm going to get myself another cross, but every time I've practiced in the past it's come up somewhere crazy. There we go. Oh, and then that happens as well, sorry. Right, let's try again. Oh. You wouldn't believe how many times I've practiced this and it's still going really badly. I'm going to draw the rest by hand. I just thought I'd show you that actually you could just do these straight onto the graph paper. So -1/4, about there, -4. So this one goes all the way down here. Okay, so what I really want you to do is now to pause the video and find some more points that would go on that graph. Okay, your choice, use as many x values, try and work out what's going on. Okay, you can plot them straight onto your Word document just by doing what I did, by pressing Insert, Shapes, finding that x, which is down here somewhere, and just clicking it on there. So pause the video, play around, see what kind of values you've got. Okay, so if you're back, hopefully you've done that pausing thing and you've got some more values on your graph. Oh, it's not going well. Right, try again. No. Just want to drag it. There we go. So I had a point at 1, 1. I had another point at, when I plotted when I plotted a half, I got 2. When I used a third, I got 3. And when I used a quarter, I got 4. Now you might have picked different values from me, but hopefully the values that you did pick were starting to show you this kind of shape. Hopefully you are better with the tech than I am. When I plotted 4, when x was 4, I got a quarter. When x was, again, it's like, it's unfailingly bad. Sorry, guys. There's an epic fail, this one. I might just leave that one there and start again somewhere else. There we go, let's try this one. Let's try moving it. No, it's not in the mood. Right, it's coming, it's coming. When I did 6, I got 0.17, so that was really small. Now, hopefully, and again, when I did it over here, I got something similar, this kind of shape over here. Now, what I want you to think about is what happened when you press 0. Hopefully, let's get the calculator back on screen. When I did 1 divided by 0, and hopefully you found out the same thing, so when I press 1 divided by 0, my calculator gets very upset and says I've got a maths error. And that's because you can't divide by 0. So what does that mean in terms of this graph overall? I'm going to switch back to my pen because I'm better with that than I am with the tech. So let's get rid of that. And yeah, I lost a bit of paper. I might just get a new one. So you need a summary page for this 1/x. And what did I discover? Well, if you looked at those crosses that were starting to appear on my graph, is that actually they formed this kind of shape. And when I do the x values, if you did what I asked and played around with the x values as well, and then some negative ones, hopefully you found this kind of shape appearing over here. Now, what do I need to know about this graph? Well, firstly, it's in 2 bits, because when I tried x equals 0, my calculator said maths error. So there's no point when x is 0. There isn't one, it doesn't exist. So there's 2 bits to 1 over x. Secondly, if you try really big x numbers, it gets really small, really close to 0, but it never actually gets to 0. So this line here, and actually I'm going to see whether I can make it show up. This line here, the axis, and this line here, this axis, are both pretty special in the graph 1 over x, because the graph 1 over x gets really close to that line, but never quite touches it. Likewise, down here, it gets really close to the axis, but it never quite touches it. And we have a special word for those lines in maths. A line that a graph gets really close to, but never actually touches, is called an asymptote. Okay, so that's a word you need to learn. Asymptote just means a line that a curve is getting closer and closer to, but is never actually touching. So the x-axis and the y-axis are both asymptotes in the graph 1 over x. So 1 over x makes this sort of shape here, and the same in this corner. And it has 2 asymptotes, the x-axis and the y-axis. Now, hopefully you're beginning to get the hang of this. We're also going to work out what does minus 1 over x look like. Well, we keep talking about the fact that it flips it that way up. So minus 1 over x, this bit here will get flipped upside down. And so that's going to end up here. And this bit here will get flipped upside down and end up here. So the same shape, just reflected vertically. Okay, so if you're feeling brave, and I've given up on the tech, so because I'm not feeling brave, I've messed this up several times in recording, so now I'm reaching for my paper. We're going to try and now look at what on earth does the graph x squared plus y squared equals 9 look like. So if you're feeling brave with the tech, you have got a bit of graph paper on yours that looks like this, but I've given up and I'm just going for a piece of paper now. Because I'm better at paper than I am trying to put crosses on the screen, as you've seen already. So the equation is x squared plus y squared equals 9. And again, I want you to do the same thing. I want you to pick an x value and find a y value that goes with it. And then pick another x value and find another y value that goes with it, and see how far you get. Now this time, I'm not doing one for you first of all. What I'm going to do is make you play first, and then I'm going to give you a bit of a hint, and then play a bit more, and then see whether you can get the hang of it. So what I'd like you to do is try and find some x values and y values that work such that x squared plus y squared equals 9, and fill them in your table, plot them on your grid, and press pause when either you've done lots and you think you know, not press pause, press play, when either you think you've done lots and you think you know what that might look like, or when you're super duper stuck and you need a bit of a hint. So if you're super duper stuck, here's me having a go. I'm going to choose my x value as 1. Okay, so the rule is x squared plus y squared equals 9. And actually what I'm going to do is do it over here in my pig pen so you can see it a bit better. So the rule was x squared plus y squared equals 9. And I've chosen an x value of 1. So 1 squared is 1, by the way, that's why I've just written 1. 1 times 1 is 1. So 1 plus y squared equals 9. And now let's get the y squared on its own, because I'd like to know what y is. So I get y squared equals 8. Now, hopefully most of you will be fairly happy to say, oh, what's the opposite of squaring? Well, the opposite of squaring is to square root. And so now I'm going to reach for my calculator, and I'm going to square root 8, and I get 2.83. So I have a coordinate 1, 2.83. There's my first cross on my graph. Okay, now I'm actually going to then just try. So if you were super duper stuck, what I'd like you to do is now just go and try and find a few more coordinates to go on that graph. if you weren't super duper stuck, or if you're back after finding a few more coordinates, how well did you do? Because actually, let's go, I'm going to go x is 0, and that was fairly straightforward. 0 squared is 0 plus y squared equals 9. So I kind of thought that y might be 3. So I did 0, 3, got a point here. But then I was thinking, hang on a minute, what else when I square it gives me 9? Because it's not just 3, is it? If we're thinking really, really hard, I think that this is also a point on that curve. Because actually, if x is 0, 0 plus y squared equals 9. So y squared equals 9. But minus 3 times minus 3 also equals 9. So actually, I think I could also plot this point down here. And likewise, I was a bit naughty earlier because I gave you this one and I worked that out with you. But actually, if I go back to over here where y squared equals 8, and I square rooted that and got 2.83, but there's no reason why I couldn't have had minus 2.83 as well, which would have got me a point down here. Now let's talk about, I don't know, well, I tried 2 next, and so I did 2 squared plus y squared equals 9. 2 squared is 4, can you see this? Yes, you can. Take away 4 from both sides gives me y squared equals 5, so then I square rooted the 5, and I got 2.24. But I also remembered all that work I did last time that said it would be also okay to have minus 2.24. So 2.24 and also minus 2.24. And then I looked at what happened when x was 3 and I got 0. And then I tried 4. Did you try 4? Try 4. If you haven't tried 4 already, see what happens when you do 4. So here's me, I'm going to try 4. So x was 4, so 4 squared is 16. Take away 16 from both sides. Gives me minus 7. Now watch what happens when I try and square root minus 7. Can you see that? Again, I've got a maths error. And so that's a bit crazy. So with 4, I don't get anything. That graph does not go as far as 4 because when I tried to work it out on my calculator said, no, there's a maths error. I can't do that. So actually, what begins to happen, and again, we'll put a summary of this in a second, is you get this kind of shape down here. And I've made this bit up because I've seen this before, and hopefully if you're not sure, you could plot some points in between and check. But also I got very similar things happening at the bottom and around here as well. So let's go to my summary page because that will be a little bit smaller and a little bit clearer. If I have something that starts x squared plus y squared equals a number, then I am absolutely always going to get a circle shape. And you probably never had a circle shape before, but every time I do x squared plus y squared equals a number, I'm going to get a circle. And that centre of that circle, if it's got this format, will always be at the origin. So that circle will always be centred on the origin. And the last thing you need to know is that this number here, the 25, if we go back to the one I did, that was equal to 9, and it had a radius of 3, that circle I was beginning to create. Interesting. So this one has a 25. This circle is going to have a radius of 5. That distance there is going to be 5, because whatever the radius is, you square it to get the number on this side. Okay, so every time I get something of the format x squared plus y squared equals r squared, then I get a circle, and the radius of that circle is the square root of that number there. So let's look at this one that I've already drawn for you. So I know, because the rules just said, we've just learned that any time I've got a circle, it's going to start x squared plus y squared. And what do I know goes on the other side? Well, on the other side is the radius squared. So the radius of this circle is 16. So I need to do 16 squared, which is 256. So the equation of that circle is x squared plus y squared, because anything that's a circle is x squared plus y squared. And then how do I get this number? Well, it's the radius squared. So lastly, x squared plus y squared equals 7. So I know x squared plus y squared, that tells me circle. So I'm going to draw a circle. And the next thing I have to do is work out the radius of that circle. How big is that circle? Well, this number here is the radius squared. So how do I know what this number is? Well, it's going to be the square root of 7, because when I squared it, I got 7. So on my calculator, I need to work out the square root of 7. And so this number here is the square root of 7. So on your summary page, you need those 3 pictures there. So all circles on graphs start x squared plus y squared. The number on this side is the radius squared. So this one had a radius of 5, so the equation of this circle is x squared plus y squared is 25. This one had a radius of 16, so its equation is x squared plus y squared equals 256, because that's 16 squared. This one, I gave you x squared plus y squared is 7. That's the radius squared. So the actual radius of this circle, square root 7. Okay? Like last one. Next up, we're going to do what we call exponential graphs. Now, exponential, I forgot to write the title. Exponential just means power. Okay, so these are graphs with powers in. So we're going to draw 2 graphs onto the same set of axes. I'm going to draw y equals 2 to the x and put my coordinates in this table, draw it in one colour. And then in this table, I'm going to work out the coordinates for y equals 3 to the x and draw that in a different colour. So again, I want you to stop, pause, play around with some coordinates, work out what those 2 graphs look like, and then when you're ready and you've got 2 graphs, come back to me and I will do something similar. So we're back, and I'm just going to work out what that graph looks like. So when x is 1, and again, I've just stuck every single one of these numbers into my calculator and worked out, actually I haven't, some of them I'm doing in my head, but I'm just working out a load of coordinates. How far do we go? 6. So 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32. That's gone off my graph, so I won't bother with 6. But I also need some negative numbers, so let's do 2 to the power of minus 2. Gives me a quarter, interesting. 2 to the power minus 4. That gave me 1/16, so 0.06, and then 2 to the power minus 6, really small, 0.015, 0.02. Okay, so now I'm going to put some of those onto my graph. So 0, 1, oh that's 2.5, so 1's going to be about there. 1, 2, about there. 2, 4, 3, 8, 4, 16, 5, too big, gone off the page. Minus 2, 0.25 is going to be tiny. Minus 4, 0.06, even smaller. Minus 6, 0.02, again even smaller. So hopefully you got this kind of shape. And then when you did the same for 3, I'm just doing this really quickly because I'm hoping you've already done this. That went through this point again, and that's quite important. All of these graphs go through this point here because anything to the power 0 is always 1. But then it went through 1, 3, and then it went through 2, 9, and then it went through 3, 27, which is huge already. Over here, I haven't done any of those. That was 0.3, 3 to the power minus 2 is 0.1, and 3 to the power minus 3, oh, really small, 0.04. Okay, so then minus 1 is 0.33, which is a little bit above that one. No, it's not. Minus 1. Oh, no, that's minus 1, sorry, that's there. Minus 2 was 0.11, just below. And then even smaller down here. Okay, and you get a similar shape, but a little bit steeper. I've put that one in the wrong place. Okay, so similar shape, but a little bit steeper. So let's put those onto your summary page. So what did I say? I said all of these look like this kind of shape. And you'll notice that it's getting really close. If we go back to these ones we were plotting earlier, it gets really, really close to the axis, but it'll never touch it. And we've got a word for that. That was asymptote. So this axis here is the asymptote because it gets really close to this, but it never quite touches it. Okay, so this was me sketching y equals 2 to the x. Next up, 3 to the x. Well, anything to the power 0 is 1, so it will go through that same point, but it's steeper than 2 to the x, because the bigger the base number on your power, the steeper the graph. And so on this side it's above, and on this side it's below. Okay, and again you need a summary of your exponential graphs. So what do I know about these graphs? Well, exponential means power, so these are all power graphs. The bigger the base number of your power, the steeper the graph. They all go through 0, 1, because anything to the power 0 is always 1, and they all have an asymptote on the x-axis. Okay, so what do you need to get out of today's lesson? Well, by the end of today's lesson, you should know what a quadratic graph looks like and have a page in your notes with those on. Know what a cubic graph looks like and have a page in your notes with the summary of that. You should know that what a 1 over x curve looks like, and you should have understood the word asymptote. You should know that any curve that starts x squared plus y squared equals some number is a circle. And finally, we've looked at some exponential graphs, and you should know that they all go through 0, 1, that the bigger the base number, the steeper the graph, and they've got an asymptote along the x-axis. If you've got all of those written in your notes, you've done a great job today.